In the early 2020s, the space component of the Copernicus atmospheric services will be extended through the addition of Sentinel 4 and 5 missions. Sentinel 4 will be a geostationary mission, whereas Sentinel 5 will be a low polar orbiting mission like Sentinel 5P. Atmospheric services are part of the Copernicus portfolio, which comprises 6 main themes: marine, land, emergency, security, climate, and atmosphere, giving a complete overview of our planet's health and its evolutions.
Can have a lot of practical applications using the data from the Sentinel 5P mission. One idea would be perhaps if we look at the harmful UV radiation, you could set up UV radiation services so that people on the street, so to speak, in the sun like today, could inform themselves how harmful it is to receive this short-wave ultraviolet radiation.
The Sentinel-5 precursor data will be combined with models and other data to develop targeted services, and they will be available as apps, social media information, or web services, so that a lot of people can choose their way they want to be informed about the environment.
Atmospheric measurements are important because especially these measurements that are done by Sentinel-5 precursor, like tropospheric ozone, information about nitrogen dioxide, sulfur dioxide, also information about aerosols, particulate matter, they have impact on the health of people. They can impact the people who have problems with their hearts or with their lungs. And as it has been shown, there are more than 400,000 premature deaths in the European Commissioning based on exposure to air pollution.
Air quality in Europe in particular, but also in the US and in Japan, got much better over the last years. That's a really big improvement. And at the same time, air quality in the developing countries, in particular in Asia, has gotten worse because they use much more energy nowadays, and that's a big source of air pollution. Also, if they are using more cars, that will pollute the air more. So it's different, it depends on where you live. In some places air quality gets better, in other places air quality gets worse. I should add that in the last 3 years, air quality in China has improved because they are very ambitious about that and have very strict rules. So they are trying to follow the European or United States path in improving air quality with better technology.
Observation from space is just one of several methods of measuring atmospheric pollution. Satellites provide the data, although they need to be calibrated with measurements on the ground.
So we are offering a comprehensive analysis, integrating data at different scales. So we are using observations, we are combined with modeling, with satellite data, and all this information is complementing each other. This is the good thing of this kind of analysis. Satellite have the advantage of providing a global picture. Trends, you can study trends very well, how the main flows are taking place. But satellite data, they don't have the resolution to get in detail in the individual processes. So here with our in situ measurements, we are getting in one particular point, and we get deeply in the detail.
The satellite gives these beautiful maps, but you can only use them really if you have a validation measurement to compare to, and this needs to be a very good measurement, and this needs to be taken on the ground. That's very important for us because we need to be very confident of the satellite data. And once you have launched the satellite, it's out of your hands and you cannot bring it to the lab and double check and test it. It's there and you need to trust the data. And the only way to get this confidence in the data is by comparison to other measurements.